Objective number 2. Know the vocabulary for polynomials. Example 1. Choose all descriptions that apply to each of the expressions. That is, A, a polynomial, B, polynomial written in descending powers, or C, not a polynomial. Part A. We have the polynomial 2x to the fourth power minus 3x cubed plus 2x squared minus 1. First of all, we choose A because this is a polynomial. We also can choose B because this polynomial is written in descending powers. Part B. We have 1 over y plus 2y squared minus 5. Notice in this case we only choose C because this is not a polynomial. The reason it's not a polynomial is if we rewrite the first term, it actually becomes y to the minus 1 power. And so in order for it to be a polynomial, all the exponents have to be non-negative integers. In other words, positive integers. And in that case, the exponent would be minus 1. So it cannot be a polynomial. So part C is appropriate. Then C. We have z squared plus 6z to the fifth power. First of all, part A is example of what we want here because this expression exemplifies being a polynomial. However, B does not apply because this polynomial is not in descending powers. Then D. We have the polynomial t plus 4. In this case, it is clearly a polynomial, and it has two terms, of course. The second thing about it is that it is in descending powers because we have the t term followed by the constant term. So both A and B apply. Example 3. Simplify each polynomial if possible. Then give the degree and tell whether the polynomial is a monomial, binomial, trinomial, or none of these. Part A. 4x squared plus 3x minus 6. Well, we cannot simplify this expression because the terms are all unlike terms. Therefore, we want to determine the degree of the polynomial. Now, the degree of this polynomial is 2 because that's the degree of the term that has the highest degree, which is the first term or the leading term. So the degree is 2. The next thing we want to do, since we can't simplify this, is to determine whether it's a monomial, binomial, trinomial, or none of these. Since this polynomial contains 3 terms, it is appropriately called a trinomial. B. Z squared plus 7z squared. Well, the first thing to note here is that these are like terms, and therefore, being like terms, we can simplify these two terms, that is, by addition. And so 1z squared plus 7z squared combines to give us 8z squared. And the degree is 2. We have a monomial here, and the degree is 2. C. Y cubed minus y squared plus 3y cubed. Again, this is a polynomial, but we can simplify it because we have 2 of the 3 terms being like terms. And therefore, the 1y cubed plus 3y cubed gives combined to give us 4y cubed, then minus y squared. Next, the degree of this polynomial in simplified form is 3 because that's the degree of the term that has the highest degree. Finally, we have to decide whether it's a monomial, binomial, trinomial, or none of these. Since this polynomial contains 2 terms only, it's binomial. D. 5x to the fourth power minus 3x cubed plus 2x squared plus x minus 1. Each of these terms is unlike, therefore we can't simplify this expression anymore. But we can determine the degree of this polynomial. And the degree, of course, would be 4. The next thing we have to decide is whether we have a monomial, binomial, trinomial, or none of these. Since this is not a monomial, certainly not a binomial, and indeed not a trinomial, so the only other response we can give is none of these.